everyone. As you know that I am doing previous year questions of strength of material from the different exams like GATE, IES and IAS. Today we are going to see the questions of bending moment and shear force diagram. Okay, we have already started last class this topic. Okay, so this is I think 22nd number video for strength of material previous year question. So if you have not watched, please watch those videos as well. It will really help you. Okay, so if you are like from mechanical engineering and from civil engineering, so it will definitely help to you. This is about myself. Okay, so I'm IIT Bombay alumni. So let's see the question of strength of material from the GATE exam. So this is I think common data question. Earlier it was coming. Let's read that. See, this diagram is given. Okay, this span is given 2000, 2000, 4000, and here is like it's a simply supported, and here it is uniformly distributed load, which concentration is 3000 Newton per meter. Okay, so a massless beam has a loading pattern as shown in figure. The beam of rectangular cross section, width is 30 mm and height is 100 mm. Okay, so this is given. So they are asking first the maximum bending moment occur at. Okay, so first they are asking where the maximum bending moment is occurring. Okay, so location at B. Okay, so their location asking occurs where. They are not asking what is the magnitude. 25 mm to the right of A, 26 75 mm this is 2500 mm right of A. Okay, so this is A and this is C, this is B. 32 25 mm to right of A. Okay, see, so what we have to do, we have to actually according to the options, we have to actually get the maximum value. So I mean, so first we have to see the, so what is the once this see what is bending moment. Bending moment, it will where shear force is 0, like if it is crossing, so where it is 0, that will give the maximum. Okay, so the first task is to get a reaction. So you know that how to get a reaction. Okay, so for this you have to write it, I mean force like this. So you multiply, I mean how you can write 3000 multiplied by 2000. Okay, so you will get concentrated loading and then equate those things. So you will get first equation, this take moment from any side, from here or from here, and then you will get, if you are taking from this side you will get R2, if you are taking from this side you will get R1. So those, I mean based on what you are taking, just put R1 or R2 in this equation, you will get R1 R2 according to what you have calculated. So once you get R1 R2, write a shear force equation at any section X from end point. Okay, so end point, let's say this is A, so at any distance X, okay, any distance X, you just write as shear force. So this is nothing but shear force. Okay, so so this will be the equation, shear force equal. So for maximum bending moment, shear force would be 0. Okay, so that will give the location. So if you put 0, okay, so I mean let's say this is X, and I mean whatever it will be, like X minus 2. I mean based on this span is given. This side, this was 2000, this side was also 2000. Okay, you see the previous slide. So you can take any side. Okay, you can take any side. Then you can take this side also, you can take here also. So here they are considering actually this is X, they are asking this. Okay, so shear force, you can take any section and just write shear force equation for maximum bending moment, that will be 0. So they have put it 0. So if you solve for X, you will get 2.5 meter. Okay, so it is nothing but 2500 mm to the right of A. So the answer is C. Okay, so I think I'm hoping you are understanding what I'm saying. Okay, next question. Okay, so what is the next question? the magnitude of bending stress. So the first question that they were asking there, what is the where it is maximum. Now they are asking what is the maximum value, maximum is, I mean moment they're not asking, they're asking what is the maximum bending stress. Okay, so see, I mean they have given the width and height of the beam, so you can write moment of inertia I dq by 12. Okay, so this is nothing but the standard expression, that is sigma m. M is nothing but bending moment. Okay, 50 I d by I dq by 12. This is the standard expression. Okay, if you don't know, anyway, what I will do, I mean, once I will finish the, I think in the previous lecture also I told this thing twice. Once I will finish this, previous year questions part, then I will come up with the complete lecture series. There I will derive, shear force equation, bending moment equation, shear force diagram, bending moment diagram for different type of loading. So these things easily you can write. Anyway, okay. So now here m is unknown. So m is we will get from, we can write like using this equation. So again this equation I cannot explain here because it will take a lot of time, like how to write these things. So anyway, just you remember this, just wait for once I will do how to write the expression for bending moment, so you will understand. Okay, now you put, so I mean where is the maximum, this x was to, in the previous equation, I mean previous question it was 2500. So this is actually not a common data question, it is a linked question. Okay, so earlier the two type question was coming, common data question, linked question. So linked question जो हमारा फर्स्ट क्वेश्चन होता है उसका आंसर यूज होता है, तो हियर दे आर यूजिंग दिस 2500. Okay, so you'll get moment. Now if you put all those value here and if you simplify you'll get 67.5 megapascal. So the answer is B. Okay, you please, I mean, watch twice, you'll understand that. Okay, next question again, it is, we'll see that it is common data or linked question based on options. So earlier was linked question, so it is like simply supported and uniformly distributed load. So what they're asking, the steel beam of breadth 120 mm and height 750 mm is loaded as shown in figure. Okay, E is given, E steel is given to 200 gigapascal. Okay, so what they're asking, the beam is subjected to maximum bending moment. Okay, so in this case they're asking what is the bending moment. We'll see that. So these are the options, that doesn't matter, we'll solve that. Okay, so what is in this case, what is bending moment is standard expression, that is WL square by 8. Okay, so these things I will derive later once I will teach the complete lecture series for strength of material. So it's like standard expression, WL square by 8. So all those things is given. If you put here, W is given 120, IL is given 50, you'll get 3375. So the answer is A. 3375 kilonewton meter. Okay, so second question, the value of maximum deflection of the beam. Okay, so these are the options. Maximum deflection they're asking. So the maximum deflection is nothing but, again this is also direct, in this case is the standard expression which is this. Okay, if you don't know, please remember from here, it is delta max is 5 by 384 WL to the power 4 by EI. So once I will teach the complete lecture series, so these things I will derive there. So anyway, as of now you remember this. So del max is equal to 5 by 384 WL by WL to the power 4 by EI. So everything is known. I think moment of inertia is in this case BHQ by 12. So all those values given in the question, you can see the previous slide. So you can calculate the I value and after that put all value here in this equation. So this is 5 by 384 into 120 into 10 by 3 into 15 to the power 4 by 200 into 10 to the power 9 into 4.22 into 10 to the power minus 3. So if you simplify this, you will get 93.75 mm. So again, the answer is A. So here this is actually common data question. This is not a linked question. So I think you understood that. Okay. Anyway, that is not required to know what type of, I mean, how they were asking question. You just see that what type of question was coming. Okay. Next question, again it is like here is written linked answer. So the first question answer will be linked with the second question. So let's read that. A simply supported beam of a span length 6 meters, 75 mm diameter carries a uniformly distributed load of 1.5 kilonewton per meter. So what is the maximum value of bending moment? Okay, so these are the options. This is also like previous question. It's like formula question. So again, it's W max, similar question, WL square by 8. So all the values is given. Just put here 1.5 into 6 square by 8. So if you simplify, you get 6.75 kilonewton meter. Okay, same question they have asked, just change the data. So the answer is E. Okay. Anyway, this option is not given, but we have to choose the nearby value. So the answer is A. Next question, obviously maximum bending stress. See, previous question they were asked the deflection, but here they are asking bending. So bending stress, like we have to bending moment also we have to calculate. I mean already we have calculated in the previous question, so that value we have to use here. So this is the value of bending stress, that is 32 m by pi d cube. So we have already calculated m value in the previous question, so we have to put here. So put 32 into 6.75 into 10 by 3 by pi, whatever it is. Okay, if you simplify this, you'll get 162.98 megapascal. So the answer is A. Little bit change was there, but similar kind of question was there. Next question, no need to read this. Okay, we'll see that a simply supported beam is subjected to a distributed loading as shown in figure. What is the maximum shear force in the beam? Okay, so this is the loading condition. They are asking what is the maximum shear force of beam. So it is actually see, the total load is half of L into B. So this is WL by 2. So shear force equation WL by 4 minus 1 by 2 into W by L by 2 into X. Okay, so you can see that WL by 4 minus WX square by 6. Okay, at any x you can write the shear stress. Okay, so at x is equal to 0, it will be WL by 4. Okay, so the nearby value will be D. So the answer is D. Next question. A simply supported beam of length L is subjected to a symmetrical uniformly varying load with zero intensity at the end and the intensity W, a load per unit length at the mid span. What is the maximum bending moment? Okay, so these are the options. Again, हम लोग simply supported इतना कर चुके हैं. Okay, so I think you can answer very easily. This is actually standard expression, that is WL square by 12. You just please remember this. You read this statement once again. It's like standard case. ऐसा कुछ इसमें नहीं है कि कुछ बताया जाए. It's a standard case. So the answer is WL square by 12. Okay, so this was the end of, I think, GATE question, second part. We'll see more question, engineering services question and civil services questions as well. Thank you for watching. Bye bye.